Circuit analysis. What is the equivalent resistance of this circuit? Alright, so since they're in parallel, we need our parallel equation. 1 over 12 plus 1 over 6. Well, we need a common denominator, so 1 over 6 becomes 2 over 12. 1 plus 2 is 3 over 12. Then we're going to flip it, and it becomes 4 ohms. Remember, the equivalent resistance of resistors in parallel is always less than the value of any individual resistor. So 4 ohms is less than both 6 and 12. Now that we have the equivalent resistance for the entire circuit, what is the voltage drop across R1? The left side of R1 is connected to the positive terminal of the battery and is at an electric potential of 16 volts. The right side of R1 is connected to the negative terminal of the battery and is at an electric potential of 0 volts. Therefore, the voltage drop across R1 has to be the full voltage from the battery, 16 volts. What is the voltage drop across R2? Just like before, the left side of the resistor is attached to the positive end of the terminal and is at a voltage of 16 volts. The right side is connected to the negative terminal and is at a voltage of 0 volts. Therefore, the voltage drop across R2 is also 16 volts. What is the current generated by the battery? We can use Ohm's law for the entire circuit. So I equals V over Req, where V is going to be the voltage provided by the battery, and Req is the total equivalent resistance of the entire circuit. So the battery is 16 volts, the equivalent resistance is 4 ohms, which we found earlier. Therefore, the current leaving the battery here is 4 amps. What is the current through R1? We can now use Ohm's law for just R1. So here's Ohm's law, but we're going to plug in numbers that only apply to R1. So the voltage drop of R1 is 16 volts, which we found earlier, and the resistance of R1 is 12 ohms, so that gives us current this way of 1.33 amps. So note, not all of the current is going to go through R1. The current's going to come around here, some of it will go that way, the rest of it will go that way. What is the current through R2? There's 2 different ways to solve for the current through R2. We could do what we did last time and use Ohm's law just for R2. So we plug in the voltage drop of R2, which is 16, and then the resistance of R2, which is 6, and we get 2.67. However, the other way to do it is to recognize that 4 amps of current are coming through this way. We already found that 1.33 of those 4 amps are going up, which means the rest of the current is going down. So therefore, 4 minus 1.33 gives us 2.67 amps. Remember, all the current coming into this junction is going to be split up between the top and the bottom branch. So those have to add up to 4. More of the current from the battery flows through the smaller resistor, then flows through the larger resistor when they're in parallel. In fact, when one resistor is half the value of the other one, like this one's 6 and that one's 12, twice as much current is going to flow through it.